So this lesson is on indirect proofs. And look on page 56. An indirect proof, okay, a direct proof, here's a direct proof, right? What's this direct proof? If A then B, if B then C, if C then D, if D then E. That is a direct proof. An indirect proof begins with not an if then. It begins with this final conclusion, suppose not E. Suppose that E is not true. Then it says, if not E, then B. And then it goes B to C. Until he gets to a statement that is false. Like, if I'm trying to prove some value is an even number in that proof that I wrote, if I would have ended up with something that I know was an odd number, then there would be a contradiction. So you go, suppose not E, if not E, then B. If B, then C. And let's suppose this is a contradiction. A contradiction is a premise that cannot be true. What's a premise that cannot be true? 3 equals 4. That's a contradiction, right? Or 3 is an even number. Or if it tells me in the proof, in the information about the proof, maybe it tells me that somebody met, let's say Paula met Thomas between 7 and 9 a.m. Okay? Between 7 and 9 a.m. If I come in the proof and it's like 10 p.m. when Paula and Thomas met, that's a contradiction of what was given. All right, so let's just walk through this proof on the bottom of page 56. It's very similar to the red and the blue, but they used red and white. All right, suppose that your hat is not red. Okay, that is my first premise. That's my first statement. This is not like the direct proofs, if A, then B, if B, then C. Your indirect proof is you're saying the conclusion is not true. And when you get to a point where there's a contradiction to the conclusion not being true, if it is false, that the conclusion is not true, then what must be true? Okay, that's a mouthful. If it is false that the conclusion is not true, then what must be true? The conclusion has to be true. A double negative makes a positive, right? So listen to the words. If it is false that my conclusion is not true, then it is true. All right, we're going to practice this. Practice makes progress. All right, so finish walking through this. Suppose your hat is not red. If your hat is not red, then it is white, right? That's what he said. Suppose the color on his back is not red. Let's suppose William did that. Suppose my color's not red. So if your color is not red, then what must be true? What's in front of you? Then someone in front of him had to have the color red, right? Is that a contradiction? Did someone in front of you have the color red? No. Do you see the contradiction? Therefore, what you supposed is not true, and in fact, the conclusion was your color was red. Okay, so let's keep walking through this. If your hat is not red, then it is white. If your hat is white, then Tom would know that his hat is red. That contradicted the fact that he didn't know what color he had. Therefore, what we suppose is false, and his hat had to be red. See, we suppose, look, what was the first statement? We suppose it wasn't red. We walked through the logic. We came to a contradiction. Therefore, what we supposed initially is not true. And so therefore the hat has to be red. All right, look on the top of the next page. You see the difference between the direct proof and the indirect proof. With the direct proof, we go if A, then B, if B, then C, if C, then D, therefore if A, then D, right? In an indirect proof, we suppose that D is not true. We suppose that the final conclusion is not true, the opposite of it. So if not D, then E, if E, then F, and so on till you reach a contradiction. And therefore, not D is false, and so D is true. Let's look at some of your homework. I'm going to record this, some of it. Let's start in number 3. I want this to be true. I want this to you to get this. Look at the example. If a tailor wants to make a coat last, he makes the pants first. If that were the statement, actually we're going to work some practice ones that I have. If that were the statement, then look what the answer is. The first statement in the proof is, suppose he doesn't make the pants first. Suppose not that conclusion. All right, so look at this statement. If those line segments are parallel, then the measure of angle 1 equals the measure of angle 2. All right, if this were a direct proof, I would say if XY is parallel to CD, then something. And I would go on to my last statement would be the measure of 1 equals the measure of 2. If I'm doing an indirect proof, my very first premise is going to be, suppose the measure of angle 1 does not equal the measure of angle 2. Do you see how these begin different? Yes? No? All right. What about this one? If M is the midpoint of segment AB, then AM equals MB. If this is the statement, then what is my first premise? If this is my conclusion, what is my first premise? What is it, Abby?
What if AM is not equal to MD?
Suppose AM is not equal to MB. That should have been MB. Are you following this? We're going to do some more. If the sap of a plant is milky, then the plant is poisonous. What is it? What's the first one? Suppose, right? Suppose.
That the plant is not poisonous.
Suppose the plant is not poisonous would be my first statement. If I'm working this proof indirectly. And I would go through the proof until I reach a contradiction. Okay? Till I reach a contradiction. Do y'all kind of understand this? Kind of. Direct proofs are harder.
I feel like the example in the book is kind of weird. The one with the hat.
Yes. All right. Let's work some homework. And I do think it will. Look at number 3. Yes, Sarah?
Do you always do it with the conclusion?
Always. The conclusion is you're supposed not. Okay? Look at statement 3. If a chicken could talk, it would speak foul language. So if I'm working this as an indirect proof, what would be my first statement, Sarah?
Suppose it does not speak a foul language.
Suppose it does not speak foul language. Are you getting this? That's the first statement. So my next statement would be, if it doesn't speak foul language, then something else, right? And I keep going till I reach a contradiction. Then what I supposed is false, therefore it must speak foul language. Do you follow that? All right, number 4. If a teacher is cross-eyed, he has no control over his pupils. What is the first statement? What is it, Therese?
The first statement, it's if a teacher is cross-eyed.
Suppose that, no.
Okay, then it's suppose he has control over his pupils.
Suppose he has control over his pupils. Right? All right. Number 5. If a proof is indirect, then it leads to a contradiction. What would be your first statement? William. Suppose it does not lead to a contradiction.